And we're still working on this Epson Equity 1, and this is our color graphics card, which I think is CGA EGA, and C8 is our tantalum capacitor that burnt and failed. So we're going to be taking that off today. And as I found from -0 degrees online, you can actually replace these with a 2-prong capacitor. Now, the only thing is I don't have any of the tantalum capacitors handy, so I'm going to be trying this with an electrolytic. Now, I did look up that, the electrolytic are not as reliable when it comes to capacitance, so there can be some issues with essentially, getting these to last. The good news is that there shouldn't be any issue with getting the card to work with a typical electrolytic aluminum capacitor. So we should be able to not only put a 2-prong on here, but get it to work at least enough to test the boot of the system. And then I can always replace this with a typical cap later. Now, nothing butts up against this in the case, so we don't have to worry about it touching anything. And at least this way we should get a pretty good idea of whether or not, this is actually a functional computer, or if there's other issues, and or, we'll have the safety goggles handy, so if anything pops or fizzes, we should be pretty well protected. But we'll go ahead and get some repair going. We'll start by taking off the old cap, and then we'll go ahead and move on to installing the new cap. We'll get the board back in the computer and basically just plug it in, see if it works. Okay, so those top 3 solder points are what we're working with here. And we're going to go ahead and give it a good old-fashioned go of it. So we're going to switch over to our soldering iron on the old solder pump. Now, I've been usually doing a lot of my soldering at 400 degrees, but I'm cranking it up to 450 here just because I want to try and desolder this a little bit better without having to use the heat gun. And unfortunately, the camera's right in my way, so you'll have to kind of forgive me. I'm sure this is not going to be perfect. Now, I do have other tips, but I kind of forgot about that and decided to just go ahead and get started instead of switching to a wider tip. So, again, apologies. I could be doing a better job of this, but we're just going to have to go with the flow a bit and hope for the best. Although I will say it's wicking up a little bit better than previous tasks I've tried. My hope is that, through this process of just testing this, it doesn't accidentally cause damage. But one thing I find really interesting is why they use something with 2 negative poles as opposed to just using a 2-pole to begin with. I assume it has something with filtering. Has something to do with filtering out noise for the video signal. But I believe this capacitor may not really be necessary overall too. Now, obviously, there's somebody out there who knows more about this than I do. So, drop me a comment. I'd be much obliged if you would actually. And just let me know, is there's something to the 3-prong capacitor over a standard 2-prong? I mean, obviously, they made these at the same time. This particular computer is a product of the 80s, so it's not like, we're limited by, the available parts of the era or anything, as far as I'm aware. So I'm just curious in that regard. It's neither here nor there at the end of the day, but the other thing is it seems like these traces are really wide, and it's almost like they're made of solder. So I'm really trying to be cognizant of that here as we're desoldering off this board. Just because I don't want to accidentally pull the trace away. And you'll have to forgive my dirty garage in the background there. And I promise that is not a big box of Oreo cakesters. That's just an empty box I used to haul some things. Happens to be a good size box if anybody out there is hauling like old floppy disk materials. Alright, so I think we got quite a bit removed here from that cap base. I'm going to add a helping hand to this to stabilize it a little bit better. So bear with me 1 second here while I reposition this a little bit more. We're actually going to kind of drop it down here, so I'll probably be repositioning the camera. I think we're going to switch over to the heat gun because I think it's in a spot where I can get a pretty good angle on it with the smaller heat gun tip. And I've been using the widest one. We're going to switch to this narrow, and hopefully that allows us to safely remove this without heating this board up too much and causing further damage. Now again, there's no guarantee that this fix I found will work, at least long term, but as far as I can tell, it's not going to cause any damage. It just may interrupt the operation of the card, so it's not ideal, which is fine. I really don't care if it's a noisy image. My major concern is that we get any image at all, and then on top of that, I want to make sure if we are getting an image that the image we do get is color. So provided it doesn't interrupt any of that, we should be okay. But just looking over kind of what we've got going on the backside, you can see the traces to the circuit here. It looks like this one, basically just it's an end-of-line capacitor, and there's a bunch of these same ones on the board, and they all appear to service the same function. They go to the same pins on pretty much everything. So I think I want to say there's a pretty good chance that the pin function of this is just to regulate end stage power. So that being the case, the capacitance should be what really counts. Now, the only electrolytic capacitor I have on hand at 10 microfarad that's close, because this is a 10 volt, is a 25. But knowing capacitors, which I'll be honest, I am a bit of a novice, it shouldn't much matter what the voltage is, provided that the capacitance rating is correct. So I'm just going to grab the capacitor from the front, heat from the back, and we'll see if she comes free. And of course I knocked my helping hand right out of there. The good news is it doesn't look like it's causing any damage. However, I am a little skeptical that I'm going to be able to pull it off of the front because there's not a lot left of this capacitor to grip. So we're going to give the old solder pump treatment and try that first. And again, I want to be really careful not to cook this board too much. I'm trying to be real intentional about not getting this too hot. Previously, I had done desoldering at 500 degrees. Got this set to 400, and I'm hoping that that's cool enough to not damage the board, but warm enough to get the solder molten. And so far, not quite there, but I think it might have been because the angle sensor on this is having a little bit of trouble. You got to kind of hold it on straight, so I'm trying to come down from the top. Okay. Yeah, it seemed to work okay there. Not quite. All right, we're going to try and temp it up. We'll go to 450 again. Just like we did with the soldering iron. And again, the goal here is to not bubble or damage the board. Wish me luck. Okay. Okay, so we're off the stand here to try and get our hot air working to desolder here. A little bit of an issue with my soldering station, but the good news is it's up and running now. All right, now it looks like we're getting some good heat. It's definitely looking molten. Oh, we're getting bits and pieces. Which means we're almost hot enough. It looks like the capacitor might just be pulling itself out, which would be tremendously helpful. Alright, give that a rest there. Alright, so we're really pretty close to having that out. Just going to try and use our little tweezer here to give it a little extra leverage. I can feel it coming free. And there we are. So let's take a look at this cap. Alright, so you can kind of see it. I'm going to try and focus up, but you can see it's just a looped negative wire from side to side. So I do think there's a pretty good argument to be made that you can run the negative to one side or another without causing damage. That's my hope anyway. Let's go ahead and fire up the soldering iron here because we'll try and do the cap next. But the pads look good. Nothing near it looks too bad. This little cap right here looks like it might have gotten a little bit warm, but that's okay. And we should have, honestly, pretty clear-cut negative on the outside, positive to the inside. I am going to go ahead and try and get the solder out here, just because I'd like to just loop the new cap through to make it as flush as I can. So I'll just get that molten. I'll try and use a little solder wick here. Well, and to be honest, wherever I can get it to go, because the negative can go on either side, frankly, I'm okay with it being on the outer. I just would like to get a nice cap job done. For once. For once, I'd like to say, wow, look at this capacitor I soldered on. Isn't that a nice solder job? I'm sure there's plenty of y'all out there just laughing at my solder jobs. I'm going to go ahead and switch to a different pump here. One that might offer a little bit more suction. I just don't want to pull the pad out. Almost. Okay, let's go ahead and swap back to our air. Oops. And if you're wondering, yes, I did just see that giant piece of solder come out and fall on the board. And yes, I will be getting that off the board before it creates an issue down the line. This is good and roasty toasty, but really would like to get all of the solder out. So we can get a nice, clean surface to mount to here. See if we can't just poke it on through. Certainly close. We'll just try and manually do that. Nothing else, we can make a hole for the leads to go through. That would be pretty nice, but I'll still just take our time. And now we got some nice copper fibers stuck to the board. That's fun. That's not going to create issues at all. So we'll try and get those off of there. All right. Now let's see here. Make sure we didn't damage any other components. Looks okay. You can see still got some of the solder wick fibers there. So we're going to grab our tweezers and see if we can't remove those. Alright, got most of it there. So that would be a real bummer to get this far and then literally solder a short onto the board. just going to get a good look at that here. Looks to be pretty clean. All right, let's get our capacitor in place. Okay, so again, this is just a test to see if this works, but we're going to put our cap through the holes here. Just make sure we have our negative to the outside, positive to the inside. Not exactly the cleanest solder pad, so you'll forgive me if I have to kind of shove this thing in here. It looks like I actually got a little hunk of solder still in there. Okay, so you'll see we've got negative there to the outside, positive to the center. We're going to leave it a little high on the board just so we can remove this later. Go ahead and bend off our leads so it doesn't slip, and let's get this back into our grips so we can solder it on. Okay, so we've got it up in our grips, which should hopefully help get this solder flowing into place correctly, and ideally this should be quick. Of course, nothing can ever go to plan here on the Urza Master channel, but that seemed to go pretty easy. Let's just double check. Looks to have good contact there. A little blobby, but not the worst in the world. All right, let's trim those leads real quick, and yeah, we'll plug it in and put our safety goggles on to see if anything pops, but hopefully that's not the case, and we can just see if it boots. This is definitely not the right tool for the job, but it is a tool for the job. I am going to leave the leads on a little long because they aren't in danger of touching anything, and it will be easier to take this off in the future if it doesn't work or if we need to. So let's get it back in the box, see how it goes. Okay, so the last time this smoked, it was basically when I plugged it in. It didn't even take a minute before something popped, fizzed, and basically started up on not quite what I would call fire, but definitely had some, shall we say, issues. So I am going to just put a little cardboard in front of myself in case anything pops. Hopefully that is not the case and everything is just hunky-dory, but I can't say I'm too hopeful. This is a pretty old computer, and it's been kept out in a warehouse that was not like environmentally controlled. So, all right, we got fan going, and so far no pops, no fizzes. I don't see any. Oh, we've got a beep. Wow. Okay. Well, let's power off our strip, and let's go ahead and plug in the video card with a composite to our monitor and test for a boot. That was unexpected. Okay, so we have a composite cable in, heading off to our monitor. Flip on our power strip. And again, no pops, no fizzes, no smoke. In terms of video signal, though, that might be a bit of a trick. Get our beep code again. Alright, so let's try and I don't believe it. Got some noise. System disk or disk errors. Insert diskette into drive A. 1985 ROM. Wow, it boots. The video signal's noisy, but it's not terrible, all things considered. I mean, the video card looks to be in good shape. Obviously, I don't have a keyboard installed right now because, frankly, I didn't think this was even going to work. But here we are. We've got the Epson Equity 1 booted. I don't have a boot disk for this, but I'll have to figure something out.